Hi, welcome to my channel. This channel is against astronomy. I say that we can go to the stars, but this video is against quantum mechanics basically, and against the quantum computers, because you cannot have such a thing. That's why I brought here like a computer. You see, it's the whole components from a computer, and I'll explain to you how a normal computer works, and where you can put the quantum computer stuff. Okay, and at the end you will see me play at my guitar here, Mama said, and this guitar is used for explaining to you even quantum computing. Okay, so if you know, I cut from a video and to show to you what they say about a subject that I'm speaking about. So that's why I cut from this Quantum Magazine YouTube channel this video, and I comment it. Okay, hope they will let me to. If not, I will refer to it. I don't know if I can post the video with cuttings from here. From this video, but if yes, you will see this video. Okay, so this video.
Here, inside this refrigerator, at a temperature just a tick above absolute zero, isolated from the rest of the universe, is a quantum computer. If you believe the hype, this nascent technology embodies the promise of the future and has the potential to revolutionize our lives with its turbocharged computation. But quantum computers aren't the next generation of supercomputers. They're something else entirely. And before we can even begin to talk about their potential applications, we need to understand the fundamental physics that drives the theory of quantum computing. We'll need to dive into another dimension, smaller and more alien than anything we intuitively understand: the subatomic world of quantum mechanics.
So if you saw that, you understand that this is the way I made my videos. I cut from some video, and you will see many minutes. It's a 10-minute video. Okay, so quantum computing. What is the quantum? What's quantum mechanics, and where you put the quantum computing stuff? Okay, so that's why I brought here like this kind of old if you know computer. Okay, I disconnect all the parts. I have here even all of it. Okay, so you know that there's some things are missing. Okay, I have two more parts like down there from the. So you know that when you disconnect something, you are missing some parts. Maybe the quantum stuff it is missing. Okay, but look, even the screws, you see I have them here, so it's complete. It is not missing the quantum stuff. Okay, so where you can put a quantum processor or something, and you do not understand that I'm telling you that the science is a lie. Okay, so techne in Greek means like technology. Okay, it is one of the word of science. You have it in English language, and everybody has this science knowledge. Okay, this is the Greek term. It's one of them. Technologos, technology. Okay, this is where it comes from. And techne was a special way of science, a practical science. Everything that you made an object with a knowledge, it is a science. It's a techne. This is technology. Okay, so this is technology. This is science. But you not understand. There's another science, theoretical science like mathematics and physics, and one is real and one is pull over your eyes to fool you, to trick you that you do not understand. So this technological science is made through inventions like light bulb, like a hydro central power plant brings you energy to your home. And this computer, it is an invention. The videotape, the audio tape, the TV, these inventions through technologos, through techne science, through technology science. from the Greek word, okay? So they are inventions for another kind of science, you want to name it, like, so I'm against, you understand, they trick you. So they pull over your eyes some theoretical bullshit, and they trick you to not understand that they made this through science, technological science, and not even through science like in a general manner, technological science, but through invention. A particular man did, the Edison made light bulbs, hydro cell power plant by Tesla, and the first, even in Romania, from where I'm from, European Union, okay, in Timișoara is a town here, the first town, one of the first towns in the world that had electricity, like light bulbs, electricity. So if you understand, a man made the invention like a car running on petrol, oil, okay, and gas, and they are they pull over your eyes some technical bullshit that are for you to not understand. So the pieces from a car, the not the technical, the a priori stuff, like in a philosophical manner, and they pretend that from that background comes that. So look another video about the quantum computers. I will get there, but let me explain to you like this, okay?
In the 1980s, one of the most important physicists of the 20th century encountered a major roadblock. Richard Feynman was hungry for a window into the quantum universe. But quantum systems, by nature, are fragile, and the information they hold hides from us. Because Feynman couldn't directly observe quantum events, he wanted to design a simulation. It quickly became clear that his computer wasn't up to the task. As he added particles to the quantum systems he was modeling, the cost of computation began to rise exponentially. Feynman concluded that classical computers just can't scale up fast enough to keep pace with the growing complexity of quantum calculations. Then he had a breakthrough. What if he could design a tool made up of quantum elements itself? This instrument would operate according to the laws of quantum physics, making it the perfect way to probe the mysteries of the quantum realm. The idea of the quantum computer was born, and by dreaming it up, Feynman had started to build a bridge between quantum physics and computer science.
So if you watch another minute, you maybe be now very impatient to hear something about quantum. But let me finish this idea, okay? It's not long. So so this is the idea. I'm not against the science, like you understand, like for you, like it's like a religion, okay? Though the science is wrong. Mathematics, pure mathematics is wrong. You are not applying anywhere. It's wrong, okay? So they pretend that again from that is derived the science is derived. So they made your telephone through knowledge, like scientific knowledge, theoretical knowledge, but they did not do this like this, okay? The videotape, you can see it on internet. It was an invention in 50s. The videotape, they had to put colors on it, and the photography was invented by accident with some chemical spillings that capture the photography, and they replicated that chemical compounds. Even still, they did not have the capacity to make a color video, and this was were inventions. And then some guy comes and defines you like angular momentum of the car, of the wheel, and things like this, and they pretend that from this angular momentum they derive the speed of the car and things like this, and the car was not exceeding the speed, maximum speed, like 200 kilometers, 300 kilometers, or ordinary, because it explodes the pistons and things from 50s, from 30s, from 1910, from the Charlie Chaplin times, okay? So they then pull over your eyes, if you understand this. I made philosophy. So that's why you see this is science. I'm not against this science. I'm against the science that they are lying with. They pretend that from physics, Feynman physics and things like this. You saw that Feynman discovered some quantum bullshit. That's tricks, and maybe they are not even, they're tricked themselves, okay? So watch another minute and you came back.
To understand how quantum computing works, it's essential to start by understanding what makes a quantum in the first place. This means that we need to talk about what's at the heart of quantum physics, a concept called amplitudes.
Quantum mechanics, at its core, is a change to the rules of probability. And this is also where the power of quantum computing comes from these different rules of probability than the ones that we are used to.
For example, if you want to know the classical probability of an event, say a coin landing tails exactly 10 times out of 20, you add up the probabilities of all the different ways that event could happen. That's just common sense. But common sense doesn't govern the quantum universe. Before you measure a subatomic particle, you can think about it as a wave of probability that exists in a kind of black box, a quantum system with many different chances of being in many different places.
So this is the video where I will comment, okay? So that's why let me tell you what was original quantum means made by Einstein. It is seemingly means a wave of light, how light moves, okay? So is the computer running with light? Yes, it's running with light, more than you believe, because the electricity is light. It is not electron energy. So now let me tell you like this. If you do not understand that these guys are lying, the computer even not computing anything. So if it is not computing anything in a traditional manner, how can you make a quantum mechanics computer if it is not computing? So these guys, you understand, they do not know what even makes the computer, and they are lying to you to interdict science from you. And that's why let's analyze the computer, all the components, to see what it is processing or computing, okay? So you have the source of electricity. You see, I'll present you on short. This source of electricity is a transformer in voltage. Okay, so because in this all kind of computers, there are three fans like this, cooling venting stuff. You see, this one is small. They're free. This big one cools this. You take the energy here and you process it in a smaller voltage, 230 voltage, okay, in Europe, and you process it because you see this fan goes at 12 volt. So watch another section from the video I am commenting, and after that you will see me show it to you how this fan works at my battery that is charged from my solar panel. So look, just for fun, okay? After you watch another small part from the quantum stuff,
Amplitudes are closely related to probabilities, but they're not probabilities. A key difference is, while probability is always a number from 0 to 1, amplitudes are complex numbers. And what this means is that they obey different rules. If I want to know the total amplitude for something to happen, I have to add up the amplitudes for all the different ways that it could have happened. But when I add up amplitudes, I see something new, which is that a particle might reach a certain place one way with a positive amplitude and another way with a negative amplitude. And if that happens, then those two amplitudes can cancel each other out, so that the total amplitude would be 0. And that would mean that that thing would never happen at all. This is sort of the central thing that quantum mechanics says about the world, right? That the way that you describe a physical system is by a list of amplitudes. And the way that a physical system changes over time is by a linear transformation of these amplitudes.
Hi, okay, look, I've told you that I have a solar panel. You see, it's like that, hooked, and here I hooked a socket, you see, and this battery, 12-volt battery, is hooked up to the solar panel. So, but it is from the video of today, like from the computer, a fan a 12 volt fan. So look, it's hooked because the battery is 12 volt. You see, it's hooked at my battery, so I can make it started through the solar panel and this car battery. So just for the fun of it, in this video, you see, and you can hear it. Okay, it's a 12 volt, so they match fan, like from the mainframe, fan. Okay, so watch the video until the end. You will hear me play Metallica, Mama Said. Okay. So you watch that. I put this still working fan, okay, from or this that's not the junk, okay. I hooked them. You see it, you can 12 volt, okay, so you can start it. You see it is hooked here at this central processor. I will get there to explain to you, and that is hooked like this, and it is cooling it, the fan, okay. So you have so you have this small fan. This is on video, this is the video processor, let's say, okay, video. It is still one on this motherboard. It is the video processor. I explain to you how it works, okay. And if you know this stuff, it is register pictures, so you have a fan. So this stuff has a motor also, because it's spinning, has a motor. This is registering pictures, is reading, if you know, okay, the hard drive, okay. So and this has another motor. If you see, this is a CD player. You put a CD here, it has a motor. So from this reasoning, this central unit of energy has multiple transformers. You see, this is different voltage, and different, you see this different voltage, and this, so you have to have different transformers. You can transform the electricity from 230 volts to 12 volts to 6 volts, or and that's why it's complex one. If you look inside, there are 3 real transformers. If you know how the electricity transformer voltage looks like. So now you have this junk. You see the cooler stuff. This is emitting thermal energy. So I'm explaining to you that I know. So because at the end you identify where is this bullshit processing, and then where is this bullshit quantum mechanics processing. So I explained to you the computer, okay. So you see this. There are few pieces in electronics. The condensers, okay, is like a dam. They put a dam on electricity to flow it in a regular manner. You understand this, to emit at what do you want, like frequency that you want. So this condenser, the resistors, like there are few pieces, if you understand. So big condensers, you see, and the transformers, this heating unit, and this electronic piece that is hooked here. You see, it emits heat, okay. So in electronics, few pieces, resistors, condensers, and then the transistor was invented for losing the signal. The big video, but I will explain to you the whole computer in this, okay. So maybe I should have said this at the beginning, but I will explain how the computer functioning, okay. To understand that this kind of quantum mechanics bullshit speaking is to trick you. Like the guy made a car. You can do this with some cutting steel machines, okay, and some guys tricking with angular momentum, with the force of the pistons, explosions and stuff like this. And some guys are lying, some guys are teaching you stuff in a real manner. So could be this a processor to process something? It is processing the voltage. It is processing the voltage, and by the way, I told you again, the electricity is not the electron. There's another light. It is the light itself, electromagnetic light. The light has many properties. So even the way of ondulation. So this is all the pieces that you have in electronics. The transistor originally were old TVs like in the telephones before that, and telegraph communications, like a light bulb that you pass a signal through it, and you add energy through the light bulb and the signal, and then the light bulb, this kind of light bulb multiply the signal. So this is the transistor. So because they're saying that they lost the signal, so at some distance the signal is lost, so you want to communicate, you translate it like in a telegraph manner. The signal was lost through the cables at some distance. That's why the first transistor was like a light bulb, exactly like a light bulb, if you know, as even in the TV, some kind of them, like a light bulb with some vibrating stuff. You pass the signal at a distance that you knew that you lost the signal, and you add energy, and the energy that it is light was converging, like multiplying your signal, exactly like duplicating a key. So this is the transistor. If you understood, this light bulb was minimized, and it's the transistor. It was minimized, not invented, for the purpose of multiplying the signal. So the more complex piece that you will find here in the computer, it is an integrated circuit. This was the second procedure to improve the transistor, like the integrated circuits. If you understand, take a signal or a picture or something, you add from another part electricity, or I'm telling you light electricity, okay, and it multiplies exactly what you introduce in them. Okay? So it multiplies your system exactly. So if you have a picture, for not to be lost and to improve on it, you pass it through integrated circuits or a transistor, and from another part you add light. So the light manages to copy exactly and multiply, duplicate. So if you saw that amplitudes and stuff like that, so there's some coherency in the pictures, and if you understand. So this is all the pieces that you will find in a computer, okay? So can this be a processor? Like it processes electricity. It processes electricity, light electricity from 230 volts. This energy was necessary to ignite a light bulb. The inventions of the light bulb suppose this voltage to if you take a light bulb and put it at a car battery, it will not work. That's why they invented a 12-volt battery. If you understand, I understand things, okay? So I'm telling you, you cannot find anywhere a quantum processor. So watch another part from the video I will comment, and you understand who is speaking more coherent. So watch.
But how can quantum computers use amplitudes to store and manipulate information quantumly? This is a qubit. It's the basic computational unit in quantum computing. Qubits are like bits in a classical computer, but with a crucial difference. A bit is binary. It stores information in strings of binary digits that can only be 0 or 1. But qubits are made of subatomic particles, so they operate according to subatomic logic. Qubits can be 0, 1, or what we call a linear combination of 0 and 1. This fluid combination of amplitudes is at the core of quantum computing. Before you measure a qubit, it exists in a state called superposition. You can think about it as a quantum version of a probability distribution, where each qubit has some amplitude for being 0 and some amplitude for being 1. Superposition is the reason why it takes a vast number of classical bits to describe the quantum state of even a tiny number of particles. When two or more qubits are in this closed state of superposition, they relate to one another through the phenomenon of entanglement. This means that their final outcomes, when we measure them, are mathematically related.
So after you watch that, so this is cannot be a quantum processor. So what it does, you understand what it does? It takes current 230 volts and it converts it to all the parts that you are needed in the computer. You have like this motor, this motor, this motor, this motor has a motor, and here there is a motor. Then for all the motors must bring electricity, because otherwise the transformer will look like this only, like this, with a few condensers, like to dam the energy and to regulate it the flow. Okay, so it will be very small. At your phone you have some inside your transformer from your phone, there is something small like this. Okay, so this transforms energy, and this was an invention, like you pull like this a bobbin from copper, and in this manner iron, and you hook the cables, you put the energy, and it was an invention. You do not know even in a perfect manner, in a physics manner, exactly why it transforms the energy like this. Even maybe they will pretend it was an invention. Okay, to not burn the circuits. Nowadays they made this powerful light energy current, because the old light bulbs, they were functioning on 200 volt. You cannot make them to emit light only in this voltage. So all the stuff from your kitchen or from drawn to electricity was obligated to support this kind of high voltage. But then they managed to make this fine stuff, like your phone. You cannot walk in your pocket with 230 volts and it will burn your phone. And this you have a external transformer, and so I explain to you big video. Okay, so this is not processing how you are believing. It is a source of current, and so you cannot put it quantum you cannot put it. Is already, if you take the energy to be electric, it is a quantum, but there's nothing quantum. Okay, it's a mechanics, a way of flowing, and okay. So then let me show to you another part. I cannot I didn't want to, I can disconnect this, okay, but I did not want it. You put the CDs, you know, okay, and there's a motor, and it is reading this, okay, this piece that it reads. You inscribe pictures here. So if you understand now, it is not processing like you are believing, you processing meat. You like separate the good meat on that. This is a kind of processor. It processes, but not how you are believing. And in this process, it comes from the process word. In this process, it is not computing how you are believing, to calculate like mathematics. It is processing picture, even when the computer shows to you 1 + 1 = 2. It is not processing it. It is having these pictures inscribed somewhere, and it is a relation, logical mathematical relation, to show to you 1 + 1 2. Like it is processing pictures. If you understand, it is not computing anything. So these guys are talking about quantum computing, even the normal computer is not computing. Okay, so you see, you have pictures here. There was a videotape, audio tape. They could inscribe even not even music on an electromagnetic audio tape on the old stuff. Even the games were inscribed on audio tapes, old audio tapes. You pull out games. So because it is an image of the sound and image of an image, so you process images, sound images and light images. So you inscribe here. It is a way of putting like a videotape in another manner, and here are inscribed real pictures in some order, and you read them in with a reading piece. Is like a diode, is like something, but it reads. when you connect it, it absorbs the pictures through it. It emits light and absorbs the picture from here. It reads it like you read with your eyes, absorb the pictures, and you convert it in a electrical light signal, exactly the pictures. I mean, it's not converting anything, and transmit it through all the computers. The picture from here, audio's picture. There's audio. It's an audio picture, like a store, like a kind of vibration, and it is, but it's a picture, okay? And so here are pictures of sound, and it transmits it through wires. You see, through wires you can transmit picture, a real picture made from light, and a coherent one, exactly you. You are stored there, exactly your picture with you. It transmits it through these wires, okay? Not this is from energy, another wires or a circuit, okay? So can this be a processor or a computing device? It is not. It's processing in a temporal manner the pictures and the sound pictures. Let process it. If you ascribe a function, how do you read it? Because if you put the picture in a temporal order like this, 30 pictures per second, and you read it 1, 2, 3, 4 to make a coherent temporal movie, okay? You cannot read them then by like this. Only if you have something that puts them back in a correct temporal manner, okay? You understand? So this, can you put it in to replace this invention from somebody with the quantum stuff bullshit? Only like in a mathematical manner, you read it like a crazy person. From some reason, not in a temporal ordered manner, but like you want to read the pictures from 2 to 2 or from 3 to 3. I don't know why. And then you put it to mess up your job, to make it harder. So can you replace this with the quantum bullshit computing? And it is not calculating anything. You understand? It's showing to you pictures. You can register. You can write pictures. There's a photo sensible thing here. That's why you see, I'll always show to you, it is showing to you all the colors. So it is susceptible, the substance is susceptible, is like painting, to all the colors. So the picture colors, okay? So you write them with a laser or with light, coherent light. You take the picture, you eject it through a cable like this, and at the tip of the cable you have a piece that it is like blowing the picture, like inscribes it, but exactly the picture. And this is a photosensible material that you can inscribe pictures on it. So now let me, so you see how I am speaking, how they are speaking. You understand who is coherent. And look, another piece from the video, okay, that I'm commenting.
The key concept for understanding how quantum computing can be powerful compared to classical computing is what we call quantum entanglement. And that is the word we use for the characteristic correlations among parts of a quantum system, which are different from the correlations that we normally encounter in the classical world in ordinary experience. You could think of it as like a book. When you look at the pages one at a time, you don't see any information, you just see random gibberish. It's because the information isn't encoded in the individual pages, but in the correlations among them. And to read the book, you have to collectively observe many pages at once. It turns out, and this is part of what's so interesting, that if you want to describe very highly entangled states using ordinary bits, it's extremely expensive.
So after you watch that, if you stick until the end, I will sing the guitar and I will explain to you even quantum mechanics, okay? So okay, we finished 2 parts from the computer. It is not calculating anything, if you understand. And there are inventions, separate inventions. Like this can be the old video tape player, put in another way. So some pieces on inside they are identical. This is another way of putting the videotape. And this is the same. This is the hard drive. this has a bigger capacity than this. So, and you can read instantly from here, okay, the movie. You can and you can you can memorize it here. You see, it's exactly like this, like you see, it has a motor. I told you it's alimentated, and it is very fine. You see, it is like a mirror, exactly like a mirror. You see, and this is also like a mirror, and you see the colors. You see, three in it, okay, and exactly like a mirror. You see this integrated circuits. I explained to you what they are doing. They are multiplying the signal that you put from a port. You add energy and it multiplies exactly to not you. Okay, so now if you understand this thing, is how small can you make a picture. This is their pixels, if you understand, or 0, 1, because this was a storage unit mathematically. This is not a calculation or a computing procedure invented mathematically, but to store on volume. If you understand, a qubit or a bit, it is a storing way of naming mathematically how you store a picture. How much space, in other words, you need to store a picture. Why? Because you saw the zoom of a picture, you make it small. How small can you make a picture? And you must realize that very, very small, since a million pictures you can inscribe here. If you even see the reading needle or inscribing needle, it does this both things. It inscribes picture and reads them. How small it is. If you see how small it is, okay. If you see, maybe I have some problems with zoom then, okay. But you can understand, okay. So now is this problem: how small can you make a picture? And the smallest unit, mathematical unit, is 0, 1 bit. So but it is a bit of storage unit. How small can you store? And this is this word information. You understand as pictures of sound and pictures, normal pictures. This is not information. Like information means like I inform you something. It's a metaphysical concept. Like I give you some information. Today we will read the tree is green. This is information. Okay, it's a philosophical concept. It is not giving you information. Only pictures. When you play, the information, metaphysical concept done by your brain, interpreting the pictures. They're showing to you some guys is singing like with a sound pictures, but you see in the sound lower. That's maybe you can describe it in pictures, okay. But if you understand, there's a maximum zoom that you can, the minimum zoom. Smaller than this, you cannot read it coherently. Like to pull it out, to make a small zoom and pull the picture out by multiplying, transmitting electricity, light electricity in it, by multiplying in coherent manner, to add some energy in a coherent manner to multiply it, to bring it to a screen. So but if you understood the explanation of this is the same. This is the same. It's a sort of multiplier of picture coherency of the picture. So is the picture made from quantum what? How they are saying, like quantum what? Quantum what? So it speaks about amplitude of a wave, like big waves, small waves, big waves, okay? And the light is not like this. It is a coherent picture. It is a unit of coherency. So it is me exactly like this when you are transmitting. You are not transmitting like waves and encode them in a picture. It is exactly a picture per second, 30 pictures to make a movie, like in Charlie Chaplin time, exactly, even still now. So what coherent waves of amplitudes you have here? because you are not even interested to speak about coherence of you are not interested to do this when you understand this stuff. It is so they are lying. So I explain you to the computer, your cell phone functioning in exactly the same manner and all. So my channel, I want to say that we can go to the stuff that you understand. I'm coherent and logical, and they are lying to you, okay? And they do not know science, and they are trick you. So who do you watch? Who do you listen? The person who tricks you, okay? So this is a small picture, like a needle point, and you send like some light through this needle and inscribes this and read it. So then transmits it through this. The signal is multiplied through the integrated circuit. There's some kind of transistors. You add current exactly from here, transformed it, to not to burn this, transformed. That's why I showed you transformed current, like diminished in capacity to not burn, because if you pass the current through two metals, separate metals, produce ohms and thermical energy. So that's why you have many unnecessary pieces in here. That's why you can minimalize it, and you cannot have the fans anymore in your phone to hear them do a mechanical work, like, and you see how bigger is a fan to cool down your phone, because your battery has a small charge voltage, so it will not burn. So that's why you do not need this many condensers and this many transformers and this many, okay? So you can they could minimalize it further than this, okay? So you have pictures, real pictures, that you are like, you do not understand this, real pictures, and the storage unit mathematically to say that you need to, for 2 bits, 3 bits, 3 qubits. You watch another video from internet, understand more about bits, but a storage unit, volume unit, or area units. So so when you define that it is 4 gigabytes, it is a storage unit, gigabytes of information, like they trick you, okay? There's a gigabyte of volume space, area, but in this case plan area, okay? Relative manner. You will believe that a flat screen will not produce three-dimensional image, but it does somehow. Okay, so you see, so can this be quantum? Can then this quantum mechanics stuff? I was messing up this image with you, and you close and the zoom goes wild, but must excuse this, okay? So let me be still, like on the same, okay? So you understand, can this quantum processing, can you ascribe pictures here smaller than this? Is a problem. You to make like a small piece and to have the same gigabyte capacity, like a terabyte capacity, but you make it small like this. Can you put small pictures like in there, not to ruin, and not to ruin the pictures to destroy the picture, okay? Like deal with the picture, and you could recuperate, and they did some like this, okay? So can this be a quantum processor? Can this be a quantum processor? In what manner? To inscribe smaller than these pictures, that to occupy the space, okay? They made this with 2-3 plaques like this, and okay, they put 2 or 3 and to increase the capacity of memory. So watch another part from that quantum video stuff, and you came back at me. I explained to you real science, okay?
Imagine that you had a primitive 10-qubit computer. It could store 2 to the 10th power values in parallel. To describe this entangled configuration with a classical computer, you'd need 2 kilobytes, or 16,000 bits. Expand to a system with 500 entangled qubits, and you now require more classical bits than there are atoms in the known universe. This is exactly what Feynman meant when he said that classical computers weren't scalable for simulating quantum mechanics. For a quantum computer to be of any use, you need to measure information from the qubits to get an output. The problem is, when a quantum system is measured, it collapses into a classical state.
If anything carries away information about whether that qubit is 0 or 1, so for example, if that information gets recorded in some radiation that's escaping from the quantum computer, then the effect on the qubit will be exactly as if someone had measured it.
So if you watch that, let me show to you this video part, okay? This is processing video. It is helping the motherboard. The motherboard has something similar, like or the video. If you observe here, this is the mainframe. There are three mainframes in this particular case, and you will see the mainframe. Let me. Maybe you'll be better. Like I don't know with the zoom. Okay. So this is the mainframe. So, but you understand what is a mainframe? Like in the picture manner, a frame. You put a picture in a frame. This is the mainframe. So what is the mainframe? Exactly this present moment pictures, or this present moment audio signal. Okay, the mainframe that you are displaying, or the okay. So what do you have here? The condensers. So the damming of the energy is necessary to not burn. You see, you must manage this. Okay, so how it is made? You put some copper. I explained to you even this. You put some copper on this like plastic sheet. It was made by all times in the radios, old radios, some kind of plastics in electronics. You see, but the electronics does not exist. But it's a nice source, way. Light energy. Electron is light. They are lying to you, okay? So you put copper like in a fine manner, and then how do you are painting a circuit? You can do this with like a printer. How you print pictures? You print the circuit, and then you put it in a solution, and the solution dissolves the copper that you do not cover with this printing. So you make a circuit. You can imagine this big to understand it. You can have big roots, but you need small kinds of energies, not burning. It's only pictures traveling through here. Pictures of sound or pictures. So this you need the smallest voltage that you can find. And to give you an idea on this is reading, if you know what this is, the RAM processor is reading 1.5 volts. This you understand that with a small battery you can manage. This is 4 gigabytes of storage of pictures. If you imagine 4 movies, you can process them with 1.5 volts. So with a small battery, you can process 4 hours of movie, more than this, and a few thousands of pictures, 10,000 pictures in a moment. Okay, in an instant, you can bring 10,000 pictures in an instant with 1.5 volts. So you understand why it is what is reading, like 1.5 voltage you pass through the. So the voltage is distributed in the picture themselves. The picture themselves are made of light energy. So if you understand, I'm telling you that even the electron does not exist. You bring high voltage light energy, many types of light. You bring it through here, 230 volts value, and I don't know what many watts, and then you convert in small voltage because to not burn your pieces. Okay, so this will help the motherboard with video processing, you see, and storage, and has a mainframe, like a mainframe. Okay, and this is an invention, like it's still a glass, like I believe like it's the same like this, like a crystal silicon glass but it's a glass here, and you understand that here are real pictures, so can this be a processor, quantum mechanics bullshit processor? Can you do this quantum? You cannot do this quantum. Once you go right, you cannot do this quantum, okay? So can this be quantum bullshit stuff? Can you make this quantum? It's like light is quantum from Einstein. Light is a quantum, but you do not need a deranged quantum of light. Like with amplitudes, how they are explaining, like waves, small waves. You need exactly a picture. A picture is a coherent way we're shooting a picture in a second. So you do not need, like, even light that it is crazy. Light that you film it in a coherent manner. So you not are working with any kind of quanta of light, okay? Quanta of light. So this is helping the video. Can you make this video? But it is processing pictures. It is showing, displaying pictures, and it's canalizing pictures through this circuit. And it is like, but you can imagine all this circuit like an instant, because the speed of light is very fast. You must understand that it is not passing light. You make the roots, but it's like everywhere, one instant. So, but you make a lot in a logical temporal manner, the circuits, but basically they're instant, if you understand. So I explained to you this. So this it is putting pictures in an instant, and it is put on the motherboard like here. So can you make this quantum? It is a problem only how small can you make a picture, okay? How small can you make a picture? And now the main motherboard, okay? Can be this quantum mechanics. Can be this quantum mechanics. Let's see. So you have this audio stuff, you see, can be the audio, a picture, quantum picture. You have this, you put a signal here. Many types of signal, and this is tricks. This is tricks because the signals is only audio on it. You can store the audio signal in a picture manner. It's a kind of frequency. You pass light, so you pass light through the audio. It copies the signal. It brings you like in a vibration per second, and it is multiplied exactly like a picture with transistors. And like in a radio old times, and with integrated circuit, and you put more energy in it, electric energy from this guy, and you send it to your speakers. The speaker is vibrating, a small needle like is vibrating according to the pictures that you inscribe, and there is a membrane made from a paper that it is vibrating after this model of vibration. But still you cannot speak, you cannot speak about quantum bullshit like frequency, because it's a precise frequency, exactly your voice. You cannot vibrate it, so you cannot process it how you are believing. You have exactly the you believe that you decompose the signal, audio signal, and then you compose it. No, you ascribe it, you memorize it exactly like the pattern of the vibration. You multiply the pattern of the vibration, you transmit it to a vibrating paper. So it is exactly a picture of your voice. You do not need amplitudes, modulations and things like that. You modulate only the voltage. If you understand, you do not burn your pieces. The volt, you modulate the frequencies of transmission of pictures. You need to take 300 pictures faster. This is you are not modeling anything. So if you not, you cannot put a quantum processor nowhere here. And you have this fan, okay, hooked or this distributor heat, because it was passing through two differential stuff, it produces heat, even the light, okay? It is in firelight. So light, it is another electron. So you have this small fan and it is put here to ventilate to cool down this, okay? So this is from here. So this is all the parts. What is computing, my friends? Quantum. See, you understand, these guys are crazy and they lie to you. They interdict science. So that's why I've told you what is techne, what is technology, and how they are lying to you. They were made through invention for a guy that did not have like 8 years of school and invented the auto tourism. Okay, so you have this small battery, you see, like to be alimentated, a small battery. You see how a small voltage you need for a picture. That's not burning your eyes. You see always, okay. But you receive a signal. It's not burning your eyes, but you see it. So it is some kind of circuit, but a small one, and you see pictures. Okay, you have it similarly like a video helping unit. You see this like a mainframe display, and you understand that this is only like a dam. You see, they are put when you introduce the signal to dam the energy, to dam it down. You see when you introduce the signal, there is dams. You see, do you not need variations? So the condensers regulate like the variation. You do not want like a big waves, incoherent. You must dumb it down. So you must calm down the picture. So you calm down with these condensers, these types. You see, when you enter the signal, they are put to dumb down the signal. But they are not doing anything. They are not processing. They are not doing anything to calm it down. Like a fellow that calms you down. Don't be patient. You see this kind. They are put when you put the signal. Look, you see. You must have a piece like this dissipates the heat, because it's producing undifferentially dissipates the heat, okay. And then to manage it, you do not need to go incoherent here, to pass like in a coherent manner a flux that you need, okay. So then you understand that this is not hard to understand. The integrated circuit is like transistor multiplier of coherent in a coherent manner. You add incoherent light energy, and from another part a coherent light picture, and you multiply it. You strengthen it. You add more sugar in it. I don't know. You make more taste the picture. So this is the mainframe. And this is the processor. This is the display, and here it is where you put the mathematical only program that it is made by Bill Gates. That's why it has money, okay? Because he managed, but it is not a mathematical procedure invented by them. But they did it. What does this mean? Well, some mathematician did this. If you are following this in a correct manner, like from Hungary, even one in a commission, but in United States, Hungarian, it's a country like near me here. It's in the border with my country, okay? So in both the countries are in the European Union, but it was American, okay? And what do you want? What do you want? You want to inscribe in a square, like your mainframe. You are seeing the pictures, and to manage to move like a pointer, like something, to give like an instruction. Do this. Show me that. Okay. But you give instruction to show you pictures, to jump from a picture to a picture. This is not processing anything. It is a mathematical way of arranging in a frame. So you make some mathematics, geometrical mathematics, to arrange and display in a frame. And the more complex program that it is processing pictures, it is Word. Because the small letters, you combine them in many variations. You can take them from a memory and put them in a page, in a mainframe. You understand? So you compose with stored picture on bits. You compose a new picture and another program that makes music. I make music, so you'll hear me sing at the end. Okay, so can this be quantum? So can be Bill Gates quantum if you do not understand the real line to you to interdict you to good jobs and things like this. And the professors, they are stupid, or entire planet. You do not understand this. They bullshit you with the physics, with Newton physics and few years, and in all of this is done like through inventions. You understand? So it is some mathematics, okay? But even in this manner, it is not invented by some guy. This is another kind of invention. You invent a music. It's a conceptual invention like this, but it is still what kind of science? So you ascribe, okay, in a square, and you can zoom it and make it small. You can put it in this corner, but always a picture. So can you do this quantum? How you make word quantum mechanics? I mean the program word, and when you writing in it, how you make it quantum mechanics from it? how you write it quantum letters? How you will make it quantum? How I'll make it quantum mechanics. Okay, so this is my video. Can be something here quantum. But if you understand, it is calculating something. It is not even calculating anything. It displays you picture in a function of time, and only done mathematically when you bring it in the mainframe on your display. And even this technology was told practically both, I don't know, from HP, like the pointer, the mouse was the more complex. Like you move here and you to display a arrow like in a given space. You see, so you have the TV invented already, but you want to influence something in the TV, to move something here and in the TV to go how you. So this was the more complex invention that you are believing, like a mouse pointer, okay? So this is the basis of the games and everything. Or at the games, they are displaying pictures, and you have a function of how to jump from this picture and this pictures. And in the mainframe, you can put many pictures like in one time. So you can pull this out, you can make it larger, okay? So like that address thing, it is mathematically. But even that you cannot make it quantum, okay? So what is quantum processing? Ways of bullshitting you and lying to you, and you do not understand even this simple thing. So I explained to you the whole old computer, okay? I've showed you that I managed to put it at my battery, that it was alimentated at the sun, sun, okay, with my solar panel, and I explained to you this here is everything. This is the whole computer. You see the whole computer. You do not have anything else left. If you want to, I will explain to you this if you want to understand that this are not processing anything. And there's a more heating distribution solution. You see, with a fan, it is put here to dissipate the heat. Maybe it was done in excess in a very warm, like in somewhere in America was invented, of course, but somewhere when it's very, 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 very hot, because you do not need this kind of many venting cooling units in all the parts of the world, because it's not heating as much as you are believing, okay? So but in Africa, or as very warm, you need all these fans and this. Okay, so that's why you can bring this in a laptop, and that's why it is smaller in your phone, because you do not need this many hookups, and so many dams. These are electrical dams, okay? And you do not need and you are not needing like a moving parts like this. A mechanical way of reading. They manage to store it, like you take the picture and store it like in an album, like static album, and then only you flow light through it. The light copies the images, it is taken, and you multiply it through a transistor or integrated circuits. They're the same thing, okay? And so you do not need a mechanical moving part to read it like this. So that's why your phone functioning, and you do not need this. And it is described, you flow current through it, light current. So it is not missing anything. This is the whole computer. You tell me where you put your bullshit computing, quantum computing stuff. Where you put it? Where? So where do you put it?
To extract an answer from the quantum system that isn't just a random outcome of probability, like the flip of a coin, we have to use interference.
You can see interference when waves in a pool hit each other, and one wave is above the surface and the other wave is below the surface, and they hit each other and they cancel each other.
Interference is just what amplitudes do when you add them up. If something can happen one way with an amplitude of a half and another way with an amplitude of minus a half, then the total amplitude for it to happen would be 0. This is what you do in the famous double slit experiment. You close one of the paths, and then you see that now the thing that previously never happened now can happen.
This is a quantum algorithm. Scientists can harness interference by creating a deterministic sequence of qubit gates. These qubit gates cause the amplitudes to add up constructively. This means that they're mathematically guaranteed to boost the probability of seeing one of the right answers.
You might ask, how could you possibly concentrate all this amplitude on the right answer when you yourself don't know in advance which answer is the right one? Well, this is exactly why designing quantum algorithms is so difficult, and why we have a whole field that's been studying it for decades.
Since 1994, there have been a few major breakthroughs in quantum algorithms, with theoretical applications in fields such as cybersecurity and search optimization. But according to most experts in the field, quantum computers are most likely to be useful for what they were born to do, when a curious physicist wondered about the deep structure of our world.
I find quantum computing exciting as a way to explore physics. Now, whether that's going to make anybody any money, whether there will be practical applications in the near term, that's still very much an open question. But at least for physicists, it's an exciting time.
The truth is, the most important application, I believe, of quantum computers is something that we don't know yet. I'm sure that once we have a quantum computer to play with, we will find amazing applications that we can't yet foresee.
So big video, but you understand, they explain to you all the computer. So the computer is not, it is processing like a process meat, but processes pictures in a process of temporal process. If you understand, it is not computing anything, and even when it calculates, it is a way of storing and jumping from a picture to a picture. There is a concept that is mathematics, arithmetic, synthetic a priori, and this means that the predicate is not correlated with the subject. So in this manner, if you understand, you must have a picture of 1, a picture of plus, a picture of 1, a picture of equal, a picture of 2. But say, so you want to put 1 plus 1 plus 1, it jumps to a picture of equal and shows to 2. So they are pictures. They are pictures. But if you understand the pocket calculators, you understand how small they can do this. Apparently calculations. They are not. They are ways of showing to you still pictures on a display. In a store manner. You okay? If you understand. So where you put your quantum stuff, my friends, where? So if you watch until now, okay, like, share and subscribe, please. you understand? I fight against the this. Like I'm telling you, you can go to the stars. They are lying to you. And to understand how much science do I know, okay? To understand I'm coherent and I speak in a coherent manner, okay? The stars are close, small, and cold. They are emitting light, not like in big vibration, voltage, and things like this. We do not need to be burning like our sun. It is no need to maintain a planet. 99% of them are smaller than the moon, and they do not have planets and blocked in clouds. That clouds produce energy, and the stars take it from there. And we cannot see the universe. The galaxies themselves are cumulus like this, static clouds pointing towards us, all of them. If you see like a sombrero, all of them. And we can go to these clouds in this current day with maybe Elon Musk rocket, okay, but to take a few years, but you can reach the stars, and they are lying to you. And do not seem crazy to you, explain to you, and they bother to explain to you all this stuff, okay? So you can go at the border of our galaxy, there's a sphere, there are clouds, and we cannot see the universe. We can traverse these clouds in many years, but we will see what is there. Okay, so that's why I do all of this, and I'm not getting money. I will do it for passion. So if you stick till now, let me sing. I will bring this down and I will sing in this chair. Metallica, Mama Said, my version. If you stick until then, this is what I want to do. Okay, this is my passion, my music. I'm a composer. You see my channel, and that's why I like music. I know a little bit, so I will sing Mama Said. Okay, goodbye. Like, share, and subscribe. The whole computer, not quantum, nothing. But if you want, I will explain to you with my guitar before I will sing Metallica why you cannot make equation for quantum. Okay. So if you were still on my channel and a long video I explained to you the computer, I want to sing Metallica. Maybe I was doing this my guitar according guitar last night. Maybe it was till now a little bit off, but I do not have time to. I will sing it like this, okay? So my version, but let me tell you on short, maybe another time I will do a video why they cannot make some coherent equations for quantum. If the light it is like an amplitude in like these chords, okay? It has all the kinds of vibration from the almost nova vibration, like in a straight line, to big vibrations, and the geometry of vibration is incoherent, like in a straight angle, in right angles, and ondulation, and all the mathematics. You cannot put all the mathematics on short, and it is in another way to understand. It's like you put all the music in one equation. You cannot do this. The light, there are waves like this with many notes. Is any like you are making a single equation for all the Mozart music. You will want to make a single equation for all the instruments like piano and all the instruments. You have the chords, the light vibrating in an amplitude modulations and frequency modulation like in a radio. You have the chords, and you can manage to see if it is infrared in a visible spectrum or bigger waves with small energy, small voltage, big watts or small watts, and big frequency, hertz frequency per second. But you cannot put it, and you understand that makes music. Light makes music. There's not a single red. There's like a music red. There are tones of red through combinations. To combinations of tonality of energies and things like this. So in a way it sings to you, the light sings to you. So can you put all the instruments like a flute and all the vibration modulation like a space-time vibration modulation from geometry in a single equation? You cannot. So if you want to capture the light, so they were lying, Schrödinger, Einstein, everybody, It is impossible. You cannot have a principle, a single common principle of a causal principle, and the equation, if you have them, should be many. 1, 2, 3, 4, and connecting logically. You cannot reduce them. That's why they are primitive and a small child like Anaximenes, to philosopher, Greek philosopher, to reduce everything to order, to energy. There's not. Einstein's false. You see, you understand this multiple causality, and you have one equation for energy, one for more ondulation, geometric, one for different wave vibration, one from time vibration, one from text exposures and things like this. And so there are some combinations like chords makes music. Okay, so in this manner you understand this amplitude, frequencies, and the color red is multiple. And you cannot put it in one equation. It's like putting all the music in pictures that's coherent structures. You emit it like this. There is no logical, a single logic that goes through a picture from a picture. A picture is like art, is like a piece of rhythm of like this. You cannot put this picture with this in. You understand? I will do the accord wrong, okay? You cannot put it in a single equation. There is temporal rhythms. So the light being like waves, amplitude, big and small, and big vibration is small, and by area, and the picture is by area, okay? You cannot put another picture, other pictures in what? In what? To define light, like the types of energy, vibration, geometry, all the geometry of mathematics has, because it describes all the objects in the world that have all the geometry. Can you put all the geometry in one equation? They're stupid child like that. So I explained to the whole computer. You do not understand it. They are tricking you to interdict you good jobs, maybe even of NASA or something, because all of them, they are inventions. The rocket and every von Braun made it, okay, and they have who they want, because they do not have any passing coherent criterion. Okay, the mathematics even can tell you is wrong and things like this. Okay, so this, if you believe me, crazy or not, but I explained to you all the computer. So Mama said from Metallica, okay, my version. Okay, let's see. Mama, she has told me when, told me when I was young. Son, your eyes are open book, look close before it's done. The brightest flame burning quickest, that's what I heard her say. It's no matter, I always find my way, only my heart go. Mama, let me be free. You see, I did not remember correctly but I know it, okay? So you cannot put them in any order. There's a logic, okay? You cannot have an equation. Let me try it again. Mama, she has told me well, told me when I was young. And your eyes are open book, so close it for me is done. The brightest flame burning kiss is what I heard her say. No matter, I'll find my way. I'll let this time go. I'll let this time be still. Let it be, mama. so this is my version, like in a quick manner, but I thought about all this stuff, and it is exactly after the video, so you can have two peace of mind, okay, and you must be in a different state of mind to sing a song, but if you hear that I can do this better maybe some other time. Metallica Mama said, so what computes quantity, what calculates, where is the quanta part appearing? Okay, so if you understood, we can go to the stars are close, and this video, like, share and subscribe. Goodbye.